Hello, this is Ibrahim Nassar with Ozone Engineering. In this demo, we will be performing an electro-thermal analysis of a high-power, low-pass coaxial filter using the ANSYS Electronics Desktop. The EM simulation will be performed using ANSYS HFSS 3D tool, and the thermal simulation will be performed using the ANSYS Icepak, which is a CFD solver, all integrated inside the ANSYS Electronics Desktop. Here's the HFSS model of the coaxial filter. In this demo, we will be using ANSYS 2025 R1, and I will show you how to do the one-way coupling between HFSS and Icepak, where we pass the EM loss to the Icepak design to run the thermal simulation. I will demonstrate in this demo two approaches to set up the Icepak simulation. The first one using the automated workflow that has been added recently, and then we will set up the Icepak simulation through the manual approach in a step-by-step manner. So here's the coaxial filter. It's made, the inner pin is made, the inner of the coax is made of aluminum, and it's filled with Teflon. And here there's a vacuum, so it's touching the background of PEC, and two ports are assigned, one from this side and one from the other side. The solution frequency is 5 gigahertz, and it's simulated. Here we can look at the S parameters, S11 and S21. So we see the low pass filters working up to kind of almost 5 gigahertz. Okay, so this is already simulated. Now, how do we take the EM losses from the calculation in HFSS to Icepak? In the latest release, you can simply do this by right-click on the HFSS design and select Create Target Design. This window will pop up. Then you select that the target design type will be Icepak. You can also go to mechanical, but for thermal simulation, we will be using the Icepak tool. And we will, if we go to the Icepak tab, we select that we need force convection, and let's use a flow speed of 1 meter per second, and the flow direction, let's put it along the length of the coaxial filter, which is along the positive z-axis. Now if we hit OK, we see an Icepak design got inserted and the geometry got transferred with all the setup ready to be simulated. We see if we expand thermal and expand EM losses, so we see that the surface loss on the inner of the coax got transferred, and the volume loss on the Teflon also got transferred. We see two boundaries inserted, one from the top and one from the bottom, an inlet and outlet. So if we double click on one of them, we see it's set up to pressure. And if we click on the inlet, we see it's set up to the velocity with a z velocity of 1 as we selected. We can now generate the mesh by right-click on mesh and select generate mesh. Okay, if we can view the mesh here on a cut plane, so we can just move it along to see how the mesh looks like, and you see it's different from HFSS because it's a different type of solve. Or we can select geometry boundary selection, and then we can click on any object and see the mesh on the object. Okay, so that's all what we need to do to simulate. So now we can right-click. We can also verify the setup one here before we run the simulation. So setup one, you see it's set up to temperature and flow with a maximum number of iteration of 100. You can control this. And we can do like this radiation is turned off, but we can use discrete coordinates. We can check the box to do turbulent. And we can check the box to include the gravity in this analysis. And we hit OK. Now we can simulate by right-click on Setup 1 and select Analyze. If we right-click on Setup 1 and select Residual, so we can watch the convergence. Now we see the simulation is done. We can go to Profile, make sure that the EM losses got transferred. So we see here that there's a volume loss came in with this value and the surface loss. These values should be same as what was calculated in HFSS. So we can go back to HFSS to verify these calculations. So if we double click on the HFSS design and we go to the HFSS field calculator, we can calculate the volume loss density and the surface loss density. To do that, we can select here from the quantity, select the volume loss density, and the geometry will be the volume, and it is the outer die. Hit OK. Then we do the integration. Then we click eval, and we see getting 0056, which is same as what got transferred to Icepak. Similarly, we can verify the surface loss density. Geometry, we change that to surface, and we want to calculate it over cylinder 8 surfaces. Hit OK. Integrate, eval, and we see 0.009 as what has been transferred into Icepak. Okay, so now we can look at the results in Icepak. What we can do, we can select these two objects where it has EM losses, and we can right-click and plot fields. Let's plot the temperature, for example. Let's plot it on the surfaces, and we hit done. So now we see this is the temperature of the model. We can also plot the flow, so we can plot it. Let's plot it on a plane, like the XC plane here in this case. So if we select the plane, then the modeler will right-click and select plot fields, velocity, and velocity vector. And here we hit done. So here's the velocity vectors. We can go also here to the results tab and click on field summary. And if let's select the geometry to be the surfaces, the adjacent surfaces, and let's select the two entities that we have, and let's click the heat flow rate, for example. Let's add this single calculation. So here it's got added. So we see the total power flow is 0.014, which is the summation of the surface loss density and the volume loss density that got calculated in HFSS and transferred to Icepak. Okay, so let's hit OK here. So this was done through the automated workflow, but we can do the same thing, but in a step-by-step approach. To do that, we can go to Project, Insert, Icepak Design. Now we can go to HFSS and manually copy the geometry. So we can select this object and this object. We don't need the vacuum for the thermal simulation. So right-click and select Edit, Copy. Then we go to the Icepak Design, and we right-click and say Edit, Paste. So here's the geometry got transferred. So what do we need to do else? We need to map the EM losses or transfer the EM losses. So we select the geometries here, right-click, or right-click here on Thermal, Assign EM loss. We're going to bring the EM losses from the HFSS design. So we select it here. And we want to check the box to simulate the source design and preserve the source design solution. Variable mapping, let's map the variables in case we need to do any parametric or optimizations. And we see that the solution frequency is 5 gigahertz, so we hit OK. And this window will pop up here, so we see the geometries that got transferred and with the EM losses assigned to, and we hit OK. We need now to assign boundaries on the inlet for the inlet and the outlet. So the outlet here, assign thermal, opening free. Let's call this the outlet. And it's a pressure boundary flow specifications pressure. And let's select the bottom surface and right-click, assign bound thermal, opening free, and this will be velocity with the velocity speed of 1. Hit OK. Before we generate the mesh, we can also add the analysis setup. So let's add a solution setup here. So we want to use check the box to temperature, flow, turbulent, discrete coordinate system, and we want to include the gravity. Convergence, let's keep the default solver settings. Change the Z velocity. Radiation, let's keep the defaults and hit OK. And now the model is ready to simulate. And this is basically what happened when we use the automated approach of transferring the geometry and the EM losses directly into Icepak. So that's it for this demo, and thank you for watching.